Here we are. Welcome to the November edition of DC604 Meetup. Today we have Shaihat, Kevin, aka Kevin, with a hands-on CTF workshop. Without any additional notes, I'm going to hand it over to Kevin. Kevin, go for it.
Okay. So hello, everybody. So let's see, how many people do we have in the room here? We've got about 26. Welcome, everybody. Tonight we're going to be working through some security challenges from the GitLab CTF, which was released last year around March. Specifically, we'll be running through about 7 challenges tonight, maybe 8 if we have a little extra time. During the workshop, if you have something that you'd like that you'd like to say, if you have some questions about what we're doing, or some of the theory behind the tricks that we're going through, please don't hesitate to unmute your mic and chime in. Let's see. I hope everybody has their security virtual machine ready, or if they're working off of your native computer, that's great too. I'll just start. Oh, I guess I'll do a little introduction about who I am. My name is Kevin. Online I go by Shaihat, and I've been learning cybersecurity for about a year and a half, a little more than a year and a half. In March, it'll be my 2-year anniversary of learning cybersecurity. So I'm relatively new to this field. So if I make some mistakes tonight, I hope you'll all forgive me. With that, I will start sharing my screen, and I hope you can follow along. Let's share that screen. That one right there. Okay, everybody. So yeah, can you see my desktop?
Yep, we can see Kelly.
Oh, nice. Okay. So everybody, let's see. Once again, I'll say that I wrote up a little guide document for everybody to use to follow along in case they get lost during the workshop. I'll drop that in. Chat. Where is the chat?
I just posted, Kevin. I just posted the guide, the link to the guide, and the link to the CTFD.
Okay. Thank you. All right. So everybody, I'd like for the workshop to be as interactive as possible. So let's see, inside of the let's see. Inside of Zoom, you should be able to do some reactions. Okay. Sorry, I'm a bit lost. Let me start the workshop. Oh, chat. Okay, I can see chat. All right, good. Sorry, I was getting a bit lost in the UI. Great.
Works best with multiple screens.
Yeah, right. Okay. So everybody, I'm going to go through the process of starting up the Docker containers because I haven't done that yet on my system. So we're just going to go into my walkthroughs directory where I have the CTF at home installed. What you need to do is you need to run your updates. Well, I find that I need to run my update scripts each time I start up the Docker containers, or else certain challenges don't show up. So I'm just going to start the update script now. That's going to pull all of the latest challenges from the server, and after that, we'll start up the Docker containers. That command, once again, you go to the folder where you have the update scripts, And then, well, I needed to run it with sudo. And you just run that. So if anybody, okay, just looking at chat now.
Keep going, Kevin. I'll ping you if there's questions in the chat.
Right, okay. So if you're following the guide PDF, this is step 2 of part 3. So that should be finishing up in just a second. I'm really tempting the gods by doing this all by doing this all live. Okay. And then to start the Docker containers, we're going to use Docker compose up. So the command is sudo Docker compose up -d so that it detaches after it's done. So that is that's part 4, step 1. Okay, and after that, all of your Docker containers should be up and running, and you should be able to access the challenges in your web browser at this address right here. It is capture.local.thetanuki.io. Okay, guys. So if you are here, if you manage to get to this screen where it says "Welcome, how to play," please type at the start in chat now. So just so I can get a gauge for who's at what step. And if there's, if you're having trouble seeing what's on the screen, or if the action is at a weird place, please chime in chat. Is anybody not able to access the challenges? Is anybody not able to access the challenges? So you should, once you get to capture.local.thetanuki.io, if you scroll down, you should be able to see over here. Oh, you guys can see the concentric circles. That's neat. So the first challenge we're going to do is CSRF over here. So is everybody ready? If you're ready, please type ready. Great. Okay. So we're going to move on past part 5. And we're going to go to CSRF, which is part 6. We're going to navigate to the CSRF 1 page. So from the challenges page, just click on CSRF over here. It's very easy. And there are 3 levels here. And we're going to navigate to CSRF 1, which is level 1 over here. Just click on that. Okay, so what is the objective of this challenge? The objective is to have the application communicate with itself. And some key information. The application takes input in the form of an absolute URL. So this challenge is called CSRF, but the address of the challenge over here is called SSRF, which is common parlance for a well-known web application vulnerability called server-side request forgery. And server-side request forgery is where we induce a web application to communicate with some backend resources that are not supposed to be available to regular users of the app. So what we want to do to solve this challenge is we want to have the application communicate with itself. And so that would demonstrate server-side request forgery attack. So we're going to move on to part 7. So part 7, we're going to check out the FAQ page for this challenge. So over here is the FAQ page right there. So we can just click on that. And it's going to give us a couple of hints. So it says here, is this service behind a reverse proxy? The answer is yes. Therefore, the service container itself is not running on port 80. Other common ports are port 3000, 4000, 5000, 8080, 88, 8081, etc. So if we were to run just a regular old communicate with itself, we would do HTTP, and then so we got all this autocomplete. But we could do like communicate with itself. Well, localhost is, yeah, this is all being given away over here. So localhost is how we might induce an application to communicate with itself. In this case, we could try port 8000, and we could try scanning that. And the response is, let's see, connection refused. So we see that connection is refused on port 8000, but we saw like a number of different ports on the FAQ page here. So we've got 3000, 4000, 5000, 8080. So 8080 is actually quite a common number for HTTP proxies. So we can try communicating on the localhost from port 8080. So let's try that. Let's see, local, and it's port 8080. I should have cleared my history before doing this. And then we scan, and that is how we solve this particular challenge. The original intent for this site was to scan security headers to see if they're set or not. In this case, along with all the regular security headers and whether they're set or not, they're all not set. Bad security there. We see that we have the flag for this particular challenge. So everybody, if you manage to access localhost 8080 and get to this page right here, please type surfs up in chat now. Dana, nice one, yeah. Sweet, sweet, sweet. Awesome. Okay, guys. So so now is a great opportunity to introduce the.
Sorry, Kevin. Guys, you can enter that flag in CTFD, and it'll give you some points, and that way we'll be able to see how many people are up to date as well.
Right, right. I was just about to mention that. So so we can see here that when we're logged into the CTFD page here, we can go to the first challenge, server-side request forgery, and then we can click on CSRF, and then we can submit the flag. Let me copy the flag real quick. Grab that thing, copy that, and then we will insert the flag, submit, and it's correct. Awesome. So we've got 7 people who are on the board here. Congratulations, guys. Okay. So everybody, if you've input the flag into CTFD here and you're on the board, please type on the board in chat. On the board. Okay, so where are we in our where are we in our guide? Okay, so we've progressed to CSRF 2, which is just past part 8. So we're going to solve the second challenge now, CSRF 2. The objective is to have the application communicate with itself again. We're going to navigate back to our homepage. Whoa. Right over here. Okay. So CSRF level 2. Click on that. Okay, and we're going to attempt the same attack from the previous exercise. Okay, so let's try that again. So if localhost worked for us before, let's try it again. So we're going to try the same SSRF attack on port 8080. And we're going to try that, and it says restricted address. So we can see that the application on this level is a little more difficult to get our SSRF attack in. So what we're going to do is we're going to go back to the FAQ page for a hint. So we go to the FAQ, and we see here, is the service behind the reverse proxy? Yes, it is. The same information here as last time. But the second question is, are redirects allowed? The answer is yes. Okay, so what we can try is we can try to get our server-side request forgery payload into the application by having it redirected as opposed to directly input. So anybody in chat, or if you wanted to chime in really quick, what's an easy way to get a URL redirect? Okay, so Dana says bit.ly. Well, yeah, that's absolutely correct. So bit.ly is a URL shortening service. So what we can do is we can we're on step 11. Okay, we're going to find and use URL shortening service. So URL shortening service is a way to get like a really long URL. We can turn it into something short and convenient. And what it does is the URL shortener, and when it's accessed, will redirect from the shortened URL to the actual URL. So what we can do is we can go to Google and we can look for URL shortener, and that will point us at bit.ly, and you can see that I've accessed it here. So bit.ly is a URL shortening service, which we can use for redirection. So we just go to bit.ly over here, and we can shorten the URL with this field right here. So if we wanted to shorten localhost, we can, which is also known as 127.0.0.1 is localhost, and port 8080. We could, well, I've already input it right here, but if you haven't, we can recreate that. HTTP 127.0.0.1 :8080, and we can shorten that. And it turns, so it turns this address into this shortened URL. So what we can do is we can copy that. It's not going to be, well, it might be the same for you, but we can use this, and we can feed this into the application to have it communicate with itself on port 8080. So we go back to the application, and then in the input field, we're going to put in our bit.ly address, and then we're going to try entering that, and that indeed works. Okay, so congratulations, we have a winner. We get all of the regular unset security headers, and we have our flag. So So everybody, if you manage to get the redirection done in some way, either through Bitly or through some other method, and you manage to get access to this flag right here, let's see, what's a great thing to put into chat? Let's say double serve. That's right. Okay, so if you've gotten here, please type double serve. Woot woot, double serve. Yeah, Bitly. Dana, you're on fire, man. All right, thanks, guys. I'm glad to see you guys are getting there. All right, guys. So let's copy this flag, and we're gonna put it into our flag collection scoreboard over here. So that's CSRF2 worth 200 points, and we're gonna plug it in here and submit. 10 solves. You guys are quick. Okay. Okay. So everybody, let's move swiftly on. If I'm going too fast for you guys, please let me know in chat. But let's see. Ryan has a fun fact. If you have a Bitly link and add a plus to the end of the URL, it won't redirect to the domain, but will show you where it will redirect to and some stats about the shortened link. Oh, Ryan, that's a great way to avoid being rickrolled. Thank you very much. Thank you very much for that. Okay, so which step are we on? We're on CSRF 3, which is just after part 12. So let's navigate back to our CSRF page, and we're going to access CSRF level 3. Ryan says, never add double plus. Is that like crossing the streams? Is something really bad going to happen if you do that? Okay, guys. So we're at CSRF level 3, and you don't want to know. So CSRF level 3 objective is to have the application communicate with itself yet again. And the key information here, the application takes input in the form of an absolute URL, but with even more restrictions. Okay. So we're on the CSRF level 3 page now. And just for fun, we're going to supply the same Bitly shortened link. Oh, that's not the Bitly shortened link. That's the flag. So let's copy that. Let's try feeding this to the application this time and see if our redirection works. Yeah. So it says here that HTTP. This is a restricted address. So even if it's redirected, 2 people have done level 3. Well, I mean, if you guys want to skip ahead and keep on the CTF train, you guys are welcome to. You guys are welcome to skip ahead of the class. It's fine. I'm here to help you guys through the challenges. But you guys, you can learn at your own pace. So the previous payload didn't work. So we're going to go to the FAQ page again for another little hint. So is the service behind a reverse proxy? Are redirects allowed? Yes. I'm stuck. Why won't you talk to yourself? So ask yourself, WWTD, what would Tavis do? Okay, and there's a little link over here. I see that it leads to Twitter. And I will just copy that link, and I will go to Twitter. Okay, so Tavis Ormandy is talking about Blizzard games. All Blizzard games, World of Warcraft, Overwatch, Diablo 3, StarCraft 2, were vulnerable to DNS Rebinding vulnerability, allowing any website to run arbitrary code. Okay, so what we're talking about is DNS Rebinding. So DNS Rebinding is a vulnerability. Sorry, I'm actually not very well versed on what DNS Rebinding is, but Amaran, I was wondering if you could explain a little bit about what DNS Rebinding is to the audience.
Well, DNS rebinding in general is when you basically have short-lived DNS settings, and so that when the browser looks up some DNS name, the DNS service responds with different IP addresses over time. But the way it's used, and this is what Tavis is referring to, the way it's often used in browser-based attacks or web-based attacks in general is to bypass same origin policies. So imagine you can convince somebody to come to your page and you resolve that name to the IP address that you control to load some JavaScript. But then later on, you're trying to make a request from that JavaScript to the same domain, but it all of a sudden now resolves to a local host. And so that way, you're basically, the JavaScript call is allowed to happen because like generally the JavaScript that runs in the context of some domain or some origin is not allowed to make web calls to different domains unless there's specific course settings. But this is a way to basically trick the browser that it's the same origin, whereas you're actually making connections to completely different web service. So if you have a service that's running locally on localhost and you can convince somebody to visit a site that you control and you do DNS rebinding, that JavaScript on the page that you control is able to make calls to that localhost and interact with that service that's bound to localhost only.
Okay, thank you very much, Amaranth.
Time of check, time of use, exactly then, yeah.
Okay, so what we can do is we can look for a DNS rebinding service to try to help us solve this challenge here. So in your favorite search engine, you can try searching for DNS rebinder. And there are some services out there on the web that let us do DNS rebinding. So we're going to use this one right here, rebinder.us. Or rebinder.us. And then we're going to use convenient web services. This page will help generate a host name for use to test for DNS rebinding vulnerabilities in software. So what we're going to do is we're going to supply 2 IP addresses we'd like to switch between. So maybe for the first address, we might want to use a famous website such as 8888, which is Google, I do believe. And maybe for the second address, oh, that's not a website, right? It's like a DNS, right? Maybe the second one is going to be our actual payload, which is 127.0.0.1. I think that's the way we do it. Let me check my notes. So we're on part 15, step 2. And what we're going to do is we're going to, so after we input these, this is dynamically generated right here. We can copy this and we can use this as the payload for our server-side request forgery attack. So we're going to copy that and then we're going to go back to our app and then we're going to plug it in with the HTTP and we're going to tag the port that we want on the end of this. So on the end of this, we're going to do :8080 and we're going to scan that. And that is the way we solve this challenge. When you submit this, it's not necessarily going to hit on the first try. So if you're having a bit of trouble with this particular challenge, you might want to submit it a few times, maybe 5 or 6. But make sure to pause in between each submission, just in case that's the submission that actually lets you through. Because if you hit it too many times, you might go back to the error state. Anyways, so that's triple serve 3. So everybody, if you are here, then please type serve 3 in the chat now.
Anybody wants to explain how it works?
Yeah, I'm definitely not an expert, but
Dana?
if anybody wants to
Gonna pick on
explain.
Dana.
Dan or Dana?
I can do it if you like.
Yes, please go ahead.
You're talking about just the rebind again, right?
Yes.
I thought Amaran had gone through this already, but we can do it a second time. So when you resolve an IP, a DNS name, a host name, you're going to an IP address. And there's a cache on your computer that keeps a list of these recently checked ones. Now, most of the time when you do a resolution, it actually will tell you how long it's supposed to save it, how long it's supposed to cache that locally. If you make that a really, really short number, say just a couple of seconds, it will go out and keep checking every couple of seconds to see if that IP address has changed. Now, the problem is when a application such as the one that we were just testing here resolves it the first time, it's going to go to a valid IP address and it's going to mark that DNS as, yes, that's good, you can use this. But when it goes to actually do it a second time or a third time, it's suddenly going to be resolving back to the local host because our malicious service here, we end up using Rbinder.
Yes.
So Rbinder is going to switch that for us really quickly. So the second time it goes back, or the third time, or whenever it happens, it's suddenly going to be on localhost. And meanwhile, the application thinks that this is an A-OK domain name because we've already checked it. It's all good. But it's not pointing to the same website anymore. It's pointing to the local host, which lets us hit at the local service again. Amaran is muted.
Yep. So there's basically a difference between when the check is done, it's resolved to one IP address that's allowed, but when the actual request happens, it's resolved to a different IP address that shouldn't be allowed.
Yeah.
Thank you very much for your explanation, guys. So with that, the CSRF challenges are done. Congratulations, guys, if you've gotten thus far. So we're going to back off to our challenges page right here, and we're going to tackle the next challenge, which is tar2zip. So everybody, let's navigate to the tar2zip page. And so the tar2zip challenge description is, can you exploit the tar2zip service? And our hint here is the flag is hidden in /flag.txt. Okay, so our objective is to get the flag string from the flag.txt file. So let's go to the tar2zip page. Okay, so we've got this nifty little web app right here. tar2zip free online service. Just use this form below to convert any tar to a zip file. That sounds pretty cool. So we're going to select a tar file to upload. So what we need to do is we need to create our own tar file. And what can we do to do that? We can go to our nifty console, and we can create a what we're going to do is we're going to take advantage of linked files. So we're going to create a linked file, and we'll explain exactly what's going on with this afterwards. But we're going to create a linked file with the ln command to create a linked file, ln-s, and we're going to create, we're going to call it flag.txt. We're going to link this to flag.txt because we know that on the server there is a file called flag.txt, and we're going to call it flag link. We're just going to call it flag link, and then we're going to create that file. So what the flag link file is it's a linked file that's linked to a file called flag.txt in the base or root directory. So the next thing we're going to do is we're going to create a tar file with that flag link file inside of it. And we do that, next command, which is tar CTF, and we're going to create a file called flaglink.tar, and the contents of that is going to be the flag link linked file. So we created the file called flaglink.tar. So if we look in here, we can see that we have a file called flaglink.tar here. So we have our tar file that we can use to interact with the application. So we're going to go to part 19 in the guide. We're going to upload the tar file to the application and download the converted file. So we go back to our browser, and we're going to upload the flag link tar file. Oops. Oh, sorry. We're going to go to Walks CTF. So here's tar flag link tar. There it is. Okay. So we're going to upload that file over here, and what returns to us is a file called converted.zip. Okay, so we're going to save that. Okay, that's going to save, and then we need to retrieve that file. So we're going to, from our working directory, we're going to move it. So move downloads/converted.zip, and then we're going to move it to the current directory, which is dot, and we're going to pass that in. So we can see here that the converted.zip file is in our current working directory. And then we're going to unzip. We're going to unzip the converted file. So we're going to unzip converted.zip. And we're going to replace the flag link file because there's already a flag link file in here. So we're going to say yes, replace that. So if we take a look at flag link, it contains the flag from flag.txt on the application server. So why is that? Does anybody want to explain why we have the contents of flag.txt and the file that we received from the application server? Okay, I'll explain it myself. So when we upload the tar file with the linked file that points at flag.txt in the root folder, when the application untars that file, then it will become linked to the file that is specified in the link file, which is /flag.txt. And since it exists on the application server, then the contents of that file it becomes a copy of that file, and that copy of the file is then zipped by the application, and then we download it to our own system. And when we unzip that, we can see the contents of flag.txt from the application server. So everybody, if you manage to collect this flag, please type in chat, "I got tarred." All right, guys. Glad you guys are keeping up all right. You can copy that flag. And so to copy from the console, please remember it's Control Shift-C instead of regular old Control-C. And we can plug that into our scoreboard. So that's number 2, Linux file abuse, Linux link file abuse. Tar to zip, plug that in and submit, and it's all good. 9 people ahead of me. You guys are fast. Okay, guys. All right. So let's move on to the next challenge. The next challenge is GTP, which is part 21. Everybody, let's navigate back to our home page, and then we can let's see, we can access GTP and OTP. These 2 challenges are linked. So on the page here, it says that these 2 challenges are to be solved in order. First, GTP needs to be done to gain access to the OTP challenge. So in GTP, it says here, the admin has a password. Can you find or guess it and log in here? Here is the source. Maybe it has some hints. So everybody, it's very important that we download the source file here. So it's frontend.tar.gz. So let's save this file. And then we're going to move that file to our working directory. So we're going to move downloads. Oops. And it's not converted one this time. It is frontend.tar.gz, and we're going to move it to our current working directory. And then we're going to, because it's a GZ file, we need to run gunzip on it. And then we will see that we have a frontend.tar file. As a result of that, we're going to untar it by doing tar xbf frontend.tar, and that's going to expand everything into the front-end directory from our working directory. So we see that we have a front-end directory here. So we got a hint from the page here that the admin has a password, and we got the front-end source. So what we can do is we can run a fun little grep command. So grep, so ir, and then we're going to pass in what we want to grep for inside of that directory, and we're going to look for the term admin because it was hinted at. So we're going to grep everything in our current working directory and any other directory recursively inside of this one with this command right here. And we see that inside the frontend db seeds.rb directory, we can see that there is a line in there saying that the username is admin and the password is admin, which is very original. So what we can do is we can try solving the challenge by logging in using these credentials. So we go back to our browser here, and we see that the login page for the OTP challenge is here. So let's go there. So from the front end, we did some source code analysis, and we determined that the username is admin and the password is admin. And so we log in and we receive a flag. So everybody, if you manage to get access to this flag, please type default credentials in chat now. All right. So what we can do is we can take the flag and we can submit it. So this is some real detailed source code analysis. I tell you what. But the next challenge is actually going to be a bit more difficult than the one that we just did. Let's move on to the next part of the challenge, which is called OTP. So, and that's the end of the guide. I wish I'd been able to write more, but work has been pretty busy. So let's go to. So this here it's looking for an OTP code. So we can come back to this, but first of all, let's access. Let's go back to the GTP and OTP page. GTP, the login here. We're going to put this in a different tab, and we see here that we still have access to the OTP challenge, which is good. And OTP, the challenge description is thus: requires GTP, see above, to be completed. Hooray, you figured the admin password, but oh bummer, admin is using a second factor. Try to bypass it to solve this challenge. However, please do not try to brute force the second factor. Here's the backend source. It definitely has some hints. Okay, so what we can do is we can download this backend source. So we click on that, and we can save this file. And just for fun, let's move this to our working directory. So it's going to be, and it's going to be otp.go. So we move it to our working directory, and what we're going to do is we're going to take a look at it inside of our favorite word editing program, Nano, which is not everybody's favorite word editing program, I'm sure. Dana says buy or die. Great. I was hoping for some controversial opinions. Okay, so we can see in here that the otp.go file, which is the Vim, make it pretty. Are you starting? Sorry, I'd never tried to start Flame Wars inside of a workshop. That doesn't seem like a very intelligent thing to do. So this is the backend source for this particular challenge right here. So we're looking for. We've got this is a Go file. I'm not particularly familiar with Go, the Go language, but we've got some functions here. So first of all, we've got this. So we've got this function here, health page, and it's going to print status OK, endpoint hit health page. Okay, so there's an endpoint called health page, and it's going to return status OK. And there's also this other function right here called verify OTP. So this seems a little more juicy. So do you guys prefer that I highlight this, or would you prefer that to just read off of the black screen? Guys, and so black if you want it on the black background, or white if you want it on the white background. Amram misses the green screen. Yeah, nice. Okay. So I guess yeah, either works for, well, okay. All right, guys. So I'll just keep on piloting like this then. So the verify OTP function is looking for username and a code, and it prints endpoint hit verify OTP. Okay. So it's also looking for some other stuff. It's looking for this new default TOTP user secret and some other stuff. All right, so we'll leave that alone for right now, and we'll go down to this last function right here. So we're looking for OTP verify username and code. So what we need is a username and a code, and we can also get this health page right here. So this is all well and good, but it requires us to do a little bit of deductive reasoning. So we're going to escape from this right now. So we're just going to get out of here, and we're going to look inside of the front end source for everywhere inside the front end code that refers to OTP. So we're going to use our good friend grep again, and we're going to look for every instance of the term OTP. And we can see that there's quite a few files that have OTP in them that we could look through. But most interestingly, inside of the front end directory, we've got these files over here that refer to OTP, such as this HTTP OTP verifier.rb. Amaran says, search for opt/verify. Maybe that's, right. Okay, so we've got opt verify inside of the HTTP verifier.rb file over here. So let's take a look at that. So we'll copy this, and then we'll cat it out. Actually, maybe we'll look at it in nano so it's a little prettier. So we'll copy that, and then we'll nano it. So we're looking at OTP endpoint. So the OTP verifier is looking for a user and a code. So the path for OTP HTTP OTP verifier is /OTP verify, and it's looking for a user ID and a code. Okay. So Amaran says you also need to understand how the verifier works. It's guessable though.
I was just responding to Dana.
Oh, sorry. Actually, this might be a good opportunity, Amaran, for you to explain the logic for how to solve this challenge, because it's a bit because I am actually not very well versed in source code analysis.
I'll be right back.
Amaran, would you like to set up your Kali box and give us a little demonstration?
Sure.
Okay. I'll stall with some jokes, while you get ready.
I'm ready.
Look, Amaran is ready.
I'll start from the other side. So far we went from kind of the back end, from OTP.go and into the front end. I'll start from the front end. So if we look at the front end, which was the same basically tar file that we downloaded for the previous challenge, under config routes.rb, this is basically this file. This is defining routes that the application responds to. And so here we see that the root redirects to or maps to top secret and the method secret in the top secret controller. And then there's also /second factor that can respond to get and post that map to TFA controller, show and verify respectively. And there's also /secret path that maps to top secret controller, the secret method. So the piece that we're going to be looking for is bypassing the second factor. So this is the part that's relevant to us. So we're going to go into the TFA, the second factor authentication controller, and see what's happening here and how it actually does the verification. So show will display the page that's asking for the code. That's the page that we're seeing when we enter the username and password correctly. And the verify will actually, once we submit the code, will do the verification. And all it does, it basically uses this HTTP OTP verifier and calls check code with the username and the code. So let's see where that is. So that file or that class is defined under lib HTTP OTP verifier. And all that check code does is it calls that backend OTP service that's defined in otp.go, and it provides and it forms the URL of the form /otp/verify, and then adds a username /code. And then essentially, if it gets a 200 response from that service, so that's checked here. If we get a 200 response from that service, then it assumes that the second factor verified successfully, and if not, it's gonna assume that it didn't. Now we can, understanding all of that, now we can take a look at the otp.go. The core piece here is, as Dana mentioned, is this init function that basically defines the paths or the routes for this backend service. And it's important that there's actually two. One is the OTP verification piece that is that /otp/verify and then username and code. And another one is health that supposedly checks the health of this backend service, whether it's okay or not. Now, again, all the front end does is it calls the service and then it checks the return code. So if we can somehow provide the values for the username and the code, that will, instead of calling this path, this URI, will call this URI. The health service always responds with the 200 status code. So this is like understanding that logic is the core for solving this challenge. So what we're going to try to do is provide some username, and instead of the code, we're going to do a little bit of path traversal and see if we can make the front end call /health instead of the OTP verify. So the username we kind of control when we log in. So we're going to have admin kind of pre-populated in there. So all we control is the code. And so we're going to do some, I guess 3 times is enough, health. And that basically makes the front end, instead of calling the right verify URL, call the /health URL, and that always returns 200, which the front end treats as the second factor has been verified successfully, and gives us the flag. Any questions on this? Did I go too fast? Yeah, app logic flaws. What I find ironic here is that even with that app logic flaw present, if there was no /health path that the backend service responds to, you couldn't exploit this. But because there is the health path, you can. Kevin, back to you.
Okay, let me share my screen again. And it is this screen, and I will share that. Okay, so everybody, so if you manage to do the path traversal attack to get to the health endpoint, and you manage to get the flag over here, what is a great, oops, where's my chat? Let me grab my chat again. What is a great thing to say here? Maybe we can say source code analyzed. Yep, or all your flags belong to us. Okay, so let's copy this and let's paste it into our good old scoreboard. And that is OTP. Let's put it in there. All right, and so the next challenge that we're going to do is called graphical. So graphical, we go back to our homepage here, and we're going to do graphical 1. So when you click on graphical one, graphical one says graphical is a project management tool with the GraphQL endpoint. There has been a report that one project contains data from a data breach of another site. Can you find it? No, if you need a hint, there just might be an endpoint for that. Winky face. Yep. Okay, so everybody, let's click on can you find it? And it's going to point us at this GraphQL endpoint over here. So I personally haven't done very much inside of GraphQL, but apparently it's a pretty powerful little piece of software for making queries. So we see here we've got project ID 4, and we're going to be. So this is the what we're going to be querying, and this is what from that particular thing we're going to return. So if we were to just press play over here to execute the query, we get data from project and a description. Oh, oh, sorry guys. This is saved from somewhere before. I really wish it hadn't saved that history. But let's before we access the flag right there, let's go through some other things we need to know. Sorry, I screwed that up, guys. So, for example, if we go to what we can do is every time we what's great about this is that we can autocomplete. We can run autocomplete on our when we're typing in here. For example, if we didn't have anything and we're just to try to autocomplete, we would do control space for autocomplete. And it gives us a number of things that are already populated in here. So for example, hint, we could do hint right here. And what from hint we can get something else. Well, we can autocomplete that too. From hint we can get text right there. So from hint we can get text, and then we can run that. So field hint is missing required arguments ID. Okay, so from hints we need to get ID. So we would do, let's see, it would be here that we get ID.
No, that's not the argument. That's what you're asking it to give you, but it's telling you about the argument in the parentheses. Yeah.
Oh, okay. So, so the ID is here. Sorry, guys. Okay, very good.
I wonder if you remove those, if you remove that ID stuff with the brackets around it, whether you'll get all the hints there is.
Oh, so if we
remove, yeah.
If we remove,
yeah, I'm just wondering if it's required, that parameter. Yeah, it looks like it is. See, okay. It's giving you the red thingy.
Right.
Yeah, so, yeah.
So we're going to put ID in here, and then we're going to run this again.
Well, you need to provide a value for ID.
Okay, so ID. So it would be ID.
Dana is suggesting we try 0.
ID 0. Let's get rid of this text. Oh man, this is what I get for not practicing. Okay. So guys, so I'm just gonna skip ahead. What we really need to do is we need to get the projects, right? So from projects, we need to get this, and we're going to look for ID, and we're going to look for name, of the thing.
Remember to use your control space to do the auto completion to find all the fields that you want to pull out.
Control space. Okay. And we can get the name, the ID, and we can get private. And we can also get the description from what I saw there. Okay, so with all these, we're going to make our query. And it so finally. So we get our projects, okay? So project ID 1 is free as in speech. It is not private. Description, awesome project for everyone. ID 2 is this, and ID 3 is this. So we see the project names. We've got 1 to 3, and we see that private is false. That's interesting. But what we can do is we can do a little bit of going beyond outside the box querying, which is useful when you're solving challenges like this. So what happens if you look for ID? What happens if you look for ID 0? Okay. We don't need ID. So, so not projects, but we're looking for a singular project, ID 0. And so it doesn't say, it doesn't know. But if we do ID 1, it finds this. If we do ID 2, it finds this, and ID 3. So we saw ID from 1 to 3 inside when we looked for all of the projects. But if we look for individual projects and we look for ID 4, which was beyond what we returned, we get this, which is the project that is called hacked data. And so this is private equals true, as opposed to the other projects where private was equal to false. And inside the description, we get our flag right here. And everybody, if you manage to solve this challenge right here and successfully use graphical, please type in the chat, I graphed it. Sorry for the technical difficulties so far, guys. Sometimes it goes that way. So we're going to go to GraphQL, graphical, and we're going to plug in our flag. Okay, guys. So we're going to, let's see, our next challenge is a cryptography challenge. And it is called Nyan. So we're going to go back. We're going to go back to our homepage, and then we're going to access Nyan over here. Nyan. Okay. Chum says IDK. That's strange. And we've got this famous meme GIF right here. But what we can do is we can download this. So we're going to save image as hint ID 1 text. Thank you, Amaran. That would have been the proper thing to look for the hint. And I've downloaded it already, but let's download it again. So we download it. We're going to replace it. And then we're going to go to our handy dandy console, and we're going to move this from downloads nyan.gif into our current working directory. Error message is confusing. Yes, it was a bit confusing. So we see is that we have that nyan.gif in here. If we were to xcg open nyan.gif, we can see that indeed it is the Nyan cat, and it is cruising through outer space. But what would happen if we were to take a look at some of the inner workings of this Nyan cat? So let's run file on nyan.gif. Okay, it says that it is GIF data. Well, that's useful. But what if we were to, example, run the strings command on Nyan? So strings nyan.gif. And if we just wanted to look for the flag, I guess we could grep for Tanuki in there. Well, okay, there is Tanuki in there, but it's not necessarily the flag that we're looking for. But we do see that some of the strings in here say things like meta -inf, and it refers to Maven. This is something I had to. Dna says he ran Stego Veritas to figure this challenge out. So did I, and I spent a long time running Stego Veritas on this file, but it didn't quite work out. But the presence of meta-inf and Maven in here refers to Java files. So could it be that this nyan.gif file is not actually just a GIF file, but is actually a Java file? Well, if that were the case, then it could be a jar file, which is a way of what is the word? Compressing your Java files. So we could run the Java command to try to extract information from this particular file with the following command: Java. Why is it displayed like that? Okay, Java -jar nyan.gif. Okay, and when we do that, it picked up these Java options and it returned to us. That was easy. The reward is this thing right here. Dana says, saw discovered trailing data, the Java app class. So I unzipped it and dropped it in JD-GUI. Good to know. Thank you. But yeah, so okay, so we have we found out that the this file was not just a GIF file, but it was a jar file in disguise. So these are called polyglot files, and they were two types of files at the same time. And I actually hadn't heard of these before before doing this challenge. But everybody, if you've managed to solve this challenge, please type nyan in celebration, and let's copy this flag and plug it in. Oh, it's 7:24 right now. Okay, we're making good time. So we're gonna move on to our last regular challenge that we're going to be covering tonight, which is the RST challenge. So we're gonna go back. Whoops, that's the wrong browser window, guys. Okay, so we're gonna go here and we're going to access the last challenge, regular challenge for tonight, RST. Okay, so the challenge description is here is another password protected area. So the hints here are the admin is admin at thetanuki.io, which I'm sure is going to come in handy when we're trying to solve this challenge right here. So it has a bunch of code right here, So what we need to take away from this is that we are defining the password reset, procedure. So if the parameters are password length is greater than 6, then it'll save the password and it'll render password changed. Otherwise, it'll say error saving password. Here it also says there is a reset. There's a password reset endpoint over here. So let's see. Okay, so let's so knowing this, let's move over to the actual application, which is rst.local. Okay, the tanuki.io over here. So what was the reset? What was the reset endpoint? Well, it was reset from the code. So we can go to reset. And when we go to the endpoint, it says error saving password. Huh. Okay, so why does it say error saving password? So if we see here in the code, it says render plain error saving password. And this is what happens if we try to reset our password and the length of the password was less than 6. Sorry, less than 6, because we're looking for greater than 6. If the length of the password was greater than 6, then the password would have been changed. That's interesting.
That's only if it found the user.
That's only if it found the user. So did it find a user? I mean, if we see that the error message was error saving password, we could try to feed a password to the reset endpoint and see if it works. So we could try feeding to the reset endpoint. We can feed it some parameters. We can feed it a password. So maybe password equals password. So if we give the parameters here to the reset endpoint, and password was password, it was password changed. But whose password was changed? If we were to just go back to the hints, and it says the admin is admin@thetanuki.io. I mean, that's the only username that we have. So if for some reason that was actually the password that was changed, sorry, let's go back to the sign-in page. We can try plugging in the only password, the only username that we have, the tanuki.io, and we can supply the password that we changed it to, which was password. We figure out that indeed it was the admin's password that we changed. But the question is why? Why was the admin user's password changed when we did this default password changing function? Do one of you guys understand the application logic inside of
Yeah. So you got to think about what that query is doing at the top of the password reset, right? It's saying get me the user where the reset password token for the token, and then it's going to be whatever that token is going to be passed in. So in a normal password reset, there would be a parameter called token. But the reality is if there's no parameter of token, it's empty. So what's happening here is this is saying, get me the first record that's empty, which in this case is the admin account, which is usually the first account on the system, right? So usually the first account in any database will be admin administrator system, something to that effect. They already told us it was admin at that email address. So the theory is if the admin would have had a password reset going on, this would have failed because they would have had a token. But because they don't, it's empty. And because it's saying, bring me back the first record or first user that's empty, we're getting the admin account. And then in that case, it's saying we have a user, it's the user ID 0, which is or 1, whatever it might be internally. And then it flows through the rest of it. So because your password was longer than 6 characters, it's going to change it to whatever you put in there. So I think you used the word password. So, and that's how that flow works. It's actually it's a logic bug because of dot first and an empty token, a parameter not being there at all. Does that make sense?
Yeah. Thank you very much. Thank you very much, Dana. You've been such a great participant for the workshop. Yeah, thank you very much. Okay, so we managed to reset the admin user's password, and then we were able to log in with that reset password. So we collected our flag. So everybody, if you managed to follow along, please type application logic in chat now. Ryan Clark says, sounds to me like we need Dana to run a DC604 workshop. I wholeheartedly agree. I think Dana would be a great workshop leader. But yeah, let's plug in. Let's plug in our last flag into the scoreboard and submit that. That is correct. So it is. So we're at 7:30. We have one more challenge we could potentially do tonight. But I'm not very well versed with it. So Amaranth, I was wondering if you would like to try your hand at leading us through the GCM challenge.
Okay. Well, I can talk through the idea, and maybe I can find the script that I've used to solve it, but I'm definitely not ready, so bear with me.
No worries. Yeah, so I mean, because I haven't really worked through the challenge, we can try to muddle our way through this first GCM challenge together. So this is GCM 1 over here.
Before we do that, anybody has any questions about the ones that we've already done?
Does anybody
so easy.
Does anybody happen to remember what the command is to increase the font size inside of your web browser, for example?
Control Shift.
Control
Or
Shift.
Control plus. It's Control Shift =.
Okay. Oh, that's much better. You guys can probably see so much better now. Okay, so this challenge is, can we break the cipher and decode the admin's token? Okay, so let's see.
Right, I'm taking over the screen share.
Oh, thank you,
Let's
Emma.
do this. All right. This is the first one. By the way, the second challenge is much more intense, but this one should not be too hard. So we've got this web application that is showing us admin token that we need to basically decrypt to get the flag. And what we can do is we can create new users. Let's say I'll name this blah, and I'll put some token and some message. All right. And so the token that I provided has been encrypted the same way as the admin token that we need to decrypt. And we can provide any token and we can get the encrypted string back. Now, the source code is important here because what we see is in the source code is two things. First is that they're using GCM mode. They're using AES-256 and they're using GCM mode. That's the first important thing. The second important, yeah, sure. It's better. There we go. So we see that they're using AES in GCM mode. So AES is the encryption algorithm, but almost any block encryption algorithm you can use in different modes. Basically, you don't just usually take a block, encrypt it with the encryption algorithm and get the block output. That's what it's called, ECB, and that's not a very good way of using encryption algorithm. There's other algorithms that basically make the output more randomized. And to understand why that's important, we can search Wikipedia for encryption modes. This is, by the way, like they've got just a brilliant picture here to illustrate why those encryption modes have been invented. So if we just, yeah, there we go. So if we just did encryption algorithm and took the message, so in this case, this picture block by block, and encrypted that block and then encrypted the next block, encrypted the next block, etc. What's usually called the ECB electronic code book. Then if we took this picture and encrypted it using that mode, we'll get this picture, which because of the way that the data is structured, they're kind of the on the lengths of the data that are over the block length, you can sometimes distinguish the structure of the data, even if you encrypt it using ECB. So the idea behind different modes is that you want ideally that output to be much more randomized than this. And so the way they do it is they mix in data, either data or like encrypted data from the previous steps into the subsequent steps, with the idea that the output will be much more random than if you just did ECB. So read this Wikipedia page. It's quite useful in understanding how encryption works and why there's different modes and how they work. So we have AES as the algorithm, AES-256. We've got GCM as the encryption mode. But most importantly, looking at this is we see that they're using static IV. So in a lot of the encryption modes, there's also this additional, in addition to the encryption key, there's additional parameter called IV. And in most cases, that IV is not secret, but it has to be cryptographically random. And in most cases, you shouldn't reuse IVs across multiple encryption operations. And in this case, they're using IV for all of their encryption operations, which is a good indication that it's very likely that this encryption can be broken. So our next step is to go and check the GCM mode, how it works. So this is basically the diagram. And the way I'm reading this is, so when you see, like, I'm identifying, here's the plain text where it's basically mixed into the output. And so the way I'm reading it is we're taking that IV and using that value to add some authentication tag, but then we increment it by 1, encrypt that counter using the encryption key, and then basically do XOR with plain text, and this is the ciphertext. So we're using that IV to essentially generate a stream of encryption keys that it is later XORed with the plain text to get the output. So if we reuse IVs between the encryption operations, that means that this stream of keys will be absolutely the same across all of those operations. So all we need to do to solve to decrypt that message and the token is we need to take the plain text that we know. So we can create that new user. We can provide any token that we want, feed it through the encryption and get the output. And then having that output, having that encrypted value, we can derive the encryption key stream that was used for that encryption. And that's going to be the same across all of the operations because of the IV reuse. So what we're going to do is we're going to generate some plain text, encrypt it, provided that as a token, and encrypt it through that web UI. We'll get the output, encrypted output. We'll devise that stream of encryption keys, and we'll use the stream of encryption keys to decrypt the admin's token. All right, let's do this. Is this big enough? Okay. If it's not big enough, shout in the chat. So firstly, I'm going to generate the plain text, and it doesn't matter what it is. What I'm going to use is I'm going to just print a bunch of A's. Let's say 64. All right, we're going to create new user, test2, provide those bunch of A's. Message doesn't matter. And we get this. This is encrypted version of that plain text that I provided. So now we're gonna GCM1. We're gonna start working on our exploit. So our plain text was, how many did I say? 32? I forgot.
64.
64. Okay. I don't actually know if we need the script. Let's do interactive thing. Okay. 64. MSG encrypted. We got this. And so this looks like base 64 encoded. It's probably also part of, yes, it's also part of the source code, but we could have guessed even if we didn't have that part. So base 64, MSG enc row. We're going to decode that base 64. Let's see what it is. Okay, so we've got this binary string now. Now let's do raw message. I think it worked. Okay, and so now we're going to derive the encryption key, the key stream. So we're going to do key stream. We'll start with empty, and then we're going to circle through the plain text, XOR it with the encrypted plain text, and that's going to give us the key stream. I'm just going to print this for now. Something's wrong. No, I guess it's not. 65? Yeah, okay. So let's What did we name the encrypted thing? MSG and CRAW. Okay, there we go. MSG and now we need to, and I keep forgetting how to do this. And so this is now, basically we have a string of those ints. We need to convert them to bytes. Add int to bytes. If anybody remembers this, let me know, because I have to look it up every time. Yeah. Let's try this. Okay. So we had, what did I name it? Key stream. Okay. So key stream. I think this should work. All right. So now we have the key stream. And all we need to do is decrypt that admin token the same way, because we just XOR it with the key stream, and that's going to be the plain text, because that's part of how GCM works. To decrypt, you generate the same, I guess there's no diagram, but to decrypt, you basically take the same IV, generate the same key stream, feed the ciphertext, and you get the plain text. So if you XOR the key stream with the ciphertext, you get the plain text. Well, I guess, there we go. Dan has a CyberChef recipe. Okay, so now we do, the message that we need to decrypt is this. Looks good. And now we're gonna do for n in range length mend. I also need the result. Here I had admin token inc raw and mix it up with the key stream. I think this should work. And we get the flag. Now, there's this crap at the end. If you go back and check how the details of how GCM works, at the end of the message, they add this auth tag that kind of serves as the sort of hash sum or control value for that encrypted value. So it's a little bit harder to generate encrypted messages that will verify, that will pass the auth tag verification. But basically the idea is if you modify encrypted message, that auth tag somewhere in the middle, that auth tag is not going to check out anymore. And that's quite important because of this XOR. So if you didn't have this, tweaking specific bits in ciphertext tweaks the same bits in the plain text upon decryption, and you could potentially alter the plain text if you know roughly the structure of the plain text. So with this auth tag, you also need to forge the auth tag to be able to do that. That's it. Now I need to check out that CyberChef thing. From base64 XOR with key XOR. Yeah, perfect. Yeah, Dan, I love it.
Like I said, basically the same thing that you were doing, just a little more graphical.
Yeah. All right. Kevin, was this all we were going to do today?
I think the timing of this has worked out pretty well. We've got about 9 minutes left before 8 o'clock. But yeah, thank you very much, Amaran, for demonstrating the GCM 1 challenge on short notice. It was actually kind of mesmerizing to watch you at work there inside of the Python interpreter there. But
was it?
But yeah. I mean, I have to admit that that I am not. I do not consider myself a very technically savvy person. But I've been trying to learn as much as I can over the last couple of years that I've been taking cybersecurity studies seriously. But everybody, I hope you all had fun running through the challenges for the GitLab CTF. I hope you were able to learn something, and or otherwise just like stretch your cybersecurity muscles out a little bit in solving these challenges. But yeah, we've got a little bit of time left. We could just throw this open to everybody in the chat. If you wanted to unmute your mics and start having a discussion about any of the topics that we covered tonight, or just anything in general, that'd be all right. But yeah, Amaran, I need to ask you, when exactly did you discover the GitLab CTF? Were you solving the challenges when the CTF came out in March of 2020?
No, I think that was their internal CTF.
Oh, okay.
They just published the challenges afterwards. I can't remember how I stumbled across it.
Hi everyone. I don't know if you can hear me.
Hey.
Yep. Yep.
Yes, hi.
Yes,
I'm outside of this. Oh, hello.
Yes, Helene, right?
Yes, exactly. I'm just calling because I'm outside of this community. I'm sorry to kind of interrupt. I'm just calling because I have some hacking issues on my side that I've been dealing with, like computer-wise, phone-wise, and I've done everything I could with Apple and my cell phone.